Hello and welcome to Optex Redwall SIP certification training. This session will discuss the features, benefits and advantages of using the Optex Redwall series of SIP or Synthesized Intelligent PIR devices. We will also cover infrared theory, unique features of the Redwall SIP, and how to install and get best performance from the product. So let's get started. Let's ask ourselves this one question. What is infrared? We have all heard the term. Our TV remotes use infrared, and infrared can also be radiated as heat. Actually, that's all infrared is. It is an energy radiated at a specific wavelength of the electromagnetic spectrum, just like visible light, X-rays, microwaves, and so on. Have a look at this chart. It shows where the infrared region lies. There's near infrared, which is just beyond the red end of the human vision at about 800 nanometers to 3000 nanometers, and far infrared from 3000 nanometers to millimeter wavelength. The property of infrared at this far range that most interests us in the PIR context is the ability of infrared radiation to warm objects without warming the air between the source and the object. The human body radiates heat at this wavelength. From now on, I will be using microns as the measurement unit for infrared wavelength. Far infrared shares some of the characteristics of visible light. That is, it can be reflected, it can penetrate or be absorbed by an object. For far infrared, glass and most plastics tend to reflect. Polyethylene can be penetrated by far infrared, so this material is used in the Redwall SIP for the lens window of the device. Human beings radiate infrared waves in the 7 to 14 micron bandwidth. This is equivalent to 7,000 to 14,000 nanometers. PIRs detect sudden changes in temperature at the far infrared wavelength and produce a corresponding electrical signal. The next statement is probably the essence of how a PIR works. PIR detectors can detect the thermal contrast between background temperature and moving objects in the detection area. If you look at the diagram, it seems there are two detectors with two fields of view. This is just because of the optics and the PIR characteristics inside the device. We will talk about that later. PIR detectors consist of these fundamental components: optics to control the PIR's vision or detection zones, sensor elements or pyro element which generate electrical signals from infrared energy, and signal processing which evaluates the signal and performs the sensor's intended function, that is, activate a relay, and the output, which of course is the dry contact relay itself. The sensor element or elements convert absorbed infrared energy into an electrical charge. They only create electrical energy when sensing temperature changes. The electrical signal will look like the bottom graph. There will be a plus spike and a minus spike because of the differential amplifier output on the back end of the pyro element. We will discuss this in the next slide. Detectors which use just one pyro element generate signals in response to any change in infrared level. This type of detector would be too sensitive to background temperature changes, heat drafts on the detector, and other environmental disturbances. Dual opposed, which means using two sensors applied to a differential amplifier, significantly reduces the effect of these false alarms. Since a differential amplifier has two opposing inputs, a plus and a minus, if the ambient background temperature changes rapidly at once, the net output from the amplifier will be zero. So the dual opposed sensor is much less susceptible to false alarms. Quad element detectors further enhance the reliability of detection. In the Redwall series, the SIP 3020 has three dual element sensors, one each for far, near and creep zones, and the SIP 100 has two quad element and two dual element devices. In a PIR, optics create detection zones by focusing incoming infrared energy onto the sensor element. In a PIR with pyro elements, there are 10 to 40 optical axes. In cameras and telescopes, there is just one single optical axis. Good PIR sensors provide multiple lenses for one pyro element. Fresnel or Fresnel lenses are used to create optical windows which control the PIR's detection area, zone size and sensitivity. However, Redwall PIRs, the SIP series, are equipped with mirrored optics. Mirrored optics can produce clearly defined detection zones for long-range detection patterns, more than 100 feet. Here's a great depiction of the mirror elements on the SIP. Shown bottom right is the masking seal templates. Basically, you peel off the desired sticker and place on the mirror to be masked. More on that later. PIRs are more sensitive to movement across its field of view and less sensitive to movement towards or away from the detector's field of view. Installation locations should be selected accordingly to allow for this. Under low brightness conditions, video motion detection sensitivity gets lower. Redwall detectors can keep the same detection performance in low or no light conditions. In addition, many false alarms are caused by insects or dirt on the camera lens. Redwall detectors do not rely on camera images to detect objects. And now some pros and cons for PIR devices. On the pro side, PIRs are single-ended devices. They do not emit any energy, so consume less power than other detectors. There's no problem with crosstalk between neighboring units. And PIRs do not require synchronized cabling for transmitters and receivers, like active beams. Precision optics enable detectors to accurately cover narrow and wide volume detection areas. And PIRs are not affected by bright lights or low light, working equally well day or night. On the con side, PIRs do not recognize the location of an intrusion accurately in a detection area. PIRs do not work well if there is not enough temperature contrast between moving objects in the background, and the possibility of false trigger by sudden temperature changes in detection area, weather conditions, wildlife, etc. So let's now look at the concept of Redwall SIP. The concept of Redwall SIP is to reduce false alarms, be very quick and reliable to install, and protect from vandalism. The 5 key points of the Redwall series is to be a high reliability PIR sensor with double conductive shielding, have a thermosensor on board for detecting environmental ambient temperature, a light intensity sensor for detecting ambient brightness, photobeam sensor for anti-masking, and an accelerometer built in for anti-rotation. Double conductive shielding is a dual conductive filter which covers the pyro element window, allowing infrared energy to pass through to the element, but blocking RFI and spurious light sources. The Redwall SIP series detectors monitor ambient temperature and luminance information for optimum sensitivity control. The Redwall SIP series detectors can reduce false alarms with optimum sensitivity even if the surrounding conditions are changing. This helps prevent missed alarms. The Redwall SIP series can detect any object covering or masking the front of the unit and will generate a trouble relay output to notify the monitoring station or system operator. When the sensor detects a shock or change of angle either vertically or horizontally, the built-in accelerometer will generate a tamper alarm relay output. Going back to the photo and temperature sensors for a minute, this shows how the SIP PIR algorithm works. Basically, ambient temperature is monitored. During a summer day, the sun will warm vegetation and trees, and as the wind moves the vegetation, that can cause false alarms. Remember the ability of infrared radiation, the sun in this case, to warm objects without warming the air between the source and the object. The SIP algorithm decreases sensitivity to prevent false alarms in this case. After sunset, which is sensed automatically with the ambient light sensor, ambient temperature decreases slowly, then increases rapidly after sunrise. During this time, the slight temperature difference between radiant human body heat and the background could cause missed alarms. Sensitivity is increased by 30% during this time. The whole point is to maximize efficiency of the device while ignoring false alarms and catching real events. During cooler months, there can be a greater temperature difference between background temperature and radiant human body heat. Under these conditions, sensitivity is decreased to avoid false alarms. You don't need the extra sensitivity when there's a greater temperature differential. Again, ambient temperature is monitored inside the SIP Redwall. Now here are some tools available to help with setup. Since the SIP is a passive device, it can be difficult to interact with it during setup. The Area Viewfinder AVF1 will help you decide which areas to mask and give a very clear idea of the Redwall SIP's field of view. Different transparent templates are available for the different models' field of view. Take for instance Area 10 in the picture above. If that was a moving shrub or plant, it may cause false triggers even with the SIP algorithm, so you can mask that area very accurately using the supplied masking stickers. There are also included masking plates to mask wider areas. After planning the area and masking, you should always perform a walk test to confirm the area. More on that later. And here once again is an example of the finger pattern you would use the masking stickers for. The small mirrors and the larger plates will be masked separately or together. Here's an example of the SIP 3020's finger pattern. This means the device can see 30 meters out and 20 meters maximum width. You can see how the finger pattern corresponds with the mirrors in the diagram. After checking the detection area with the AVF1, use the provided masking plates to narrow the detection area of unwanted areas. You can also use the detection area switches to individually turn on or off the far or near zones. This means a reduced number of false alarms generated around the far edge of the detection area. So basically the SIP Redwall does not need to be mounted like this. We have high mounting, reinforced polycarbonate housing, and anti-masking, anti-rotation features as a counter against vandalism. So most unique features on the SIP Redwall. The Redwall can be mounted anywhere between 7.6 and 13 feet, keeping the device safe from possible vandalism. At 7.6 feet mounting height, the built-in creep zone detector provides a 10 by 16 foot detection zone directly below the sensor, which eliminates the normal dead space where an intruder could enter a protected area. An independent alarm relay output from the creep zone can trigger a PTZ camera to a programmed preset position and provide coverage for a dead spot. Also good to note is that the SIP 100 offers 3 separate alarm relay outputs with near area detection, far area detection, and creep zone detection. Multiple outputs are useful for activating video management systems and controlling PTZ cameras. So here's the Redwall product lineup. You can work out the coverage of the device from the model number. For instance, the SIP 5030 has a finger pattern which extends 50 meters and is 30 meters wide. That corresponds to 165 by 100 feet. The /5 models all have the creep zone detector, as well as the SIP 100 and SIP 5030. The WF models are very low power, operating at 3.6 volts DC with a standard standby current of 40 microamps. Also available is a new package, the SIP 3020, 4010, 404WI models. These are much the same as the WF models, but with included Innovonics wireless transmitter and black box. These are some of the available optional accessories. For setup, the AWT3 and AVF1 are mandatory. We have a range of mounting accessories for any situation, including pole mount brackets, mounting plates, and sun hoods, such as the SIP mini hood and SIP MIDI hood. Now here are some things to consider before installation of the SIP Redwall. Situations like this, where authorized people are walking in the protected area, need careful planning. Changing the mounting location and use masking if necessary will alleviate these issues. Another challenge is objects that can cause false alarms, such as a flag waving in the wind. You can mask those to avoid detection. Now, overspill is another problem where beyond the field of view of the SIP is picked up in the far zone. You should readjust the mounting position or mask as necessary. Detection area and cameras should be set accurately within the property boundaries. If needed, you can also turn off the far zone. Here's another example of overspill. So again, you should either adjust the angle of the device or use far zone masking. Or again, turn off far zone, providing you don't need it. So here's some more ideas on overspill. To reduce the detection area, area masking is the proper technique. But as shown, when area masking results in missed alarms, the detection area should be changed by adjusting the sensor head downwards. And to avoid detection beyond the fence, aiming the detector downward will solve the problem. But as shown, the sensitivity of the lower zone increases. Therefore, lower sensitivity setting for this zone should be selected to avoid false alarms. Wildlife, dogs, cats, raccoons, whatever, can in fact trigger the SIP Redwall. But because of the built-in intelligence of the device, there is a sensitivity detection algorithm built in that can alleviate these nuisance alarms. Now let's have a look at some poor installation practices. This detector was installed next to a pillar and cannot be adjusted towards the area of detection. So the location of the detector should be carefully planned before installing the unit. These detectors were painted to match the wall they are mounted on, which is okay, except they also painted the lens of the detector, blocking its field of view. The painted segments cannot see. So keep the optics clean and free from debris. If there is an obstruction in the detection area, the detector cannot see the target beyond it. So in cases such as raise the mounting height of the SIP to see over the obstruction. When the SIP is installed on an uneven grade, problems to address are overspill, false detection due to ground proximity, and dead spots. These can be addressed by either changing the mounting height of the device, changing the mounting angle, or adjusting sensitivity where necessary and masking. Redwall SIP detectors should not have any dead spots when installed at the correct height, 7.6 to 13 feet. However, there are dead spots at a mounting height of 26¼ feet, which is out of device specification. When mounted above specification, sensitivity will be too low to detect the target. So here are some system design hints and tips. The question to ask yourself is, what does the system protect? Is it the perimeter line? Is it just around the building? Or is it between the building and the perimeter? And please note that Redwall products are designed to trigger video surveillance systems. Next question, how big is the site? Calculate the area of detection required, both in length and width. Then select the proper Redwall SIP model that matches the closest size of the required detection area. And lastly, confirm the detection area can be covered by the camera. Mismatching detection area and camera views means that operators cannot see the coverage area, possibly missing the event. The detection area should be within the camera view. And now some notes on the location of the installation. Install the sensor so that the majority of target activity is across the detection pattern. The mounting height should be between 7.6 and 13 feet. And mount the sensor on a wall or other solid surface. Do not install in locations where excessive vibration may cause false alarms. If there are obstacles in the detection area, mount the unit at a higher point, up to 13 feet. This will help eliminate dead spots. Direct or reflected sunlight on the face of the sensor can cause false alarms. So set the detection area so it is not affected by direct sunlight, or use the optional sun hoods, the SIP mini hood or the SIP midi hood, to avoid this problem. Install the Redwall SIP series away from objects which can block the detection area. Now, sensor positioning, of course, is very important. So in this particular case, overspill on the road may be a problem with the drawing on the left. A better solution would be to mount the detector as in the picture on the right. This way, overspill is avoided and targets will walk across the detection finger pattern through the gate. And this will also protect the wall running parallel with the finger pattern. The main point here is know and use the finger pattern of each device. They are available for download online at www.optexamerica.com/Redwall. So here are some notes on detection. Sensors should only trigger within the field of view of the camera. PTZ cameras should be considered as multiple fixed cameras using presets. Do not connect multiple sensors to a single input. And for verification purposes, a person should cover 10% of the picture height. The maximum zone length is approximately 160 feet. For recognition purposes, a person should cover 50% of the picture height. And here's a quick chart on how to select the correct lens for any given detector. If the camera's field of view cannot cover the whole detection area, add another camera to cover the entire zone. And here's a quick word on something very obvious: lighting. Good practice states that adequate lighting must be installed before the system is commissioned, and reference images should be stored from all cameras and detector presets. Here's a quick note on wiring. Make sure that you're using the correct gauge wire for the voltage and the cable run you have planned. Now let's go to the switch settings of the SIP. The first one is the sensitivity selector switch. So here are some guidelines. If the SIP is installed at 7.6 feet, the factory default position is M, or medium sensitivity. When conducting the walk test, set the switch at the SH, or super high position, and after confirmation of the detection area, adjust to the proper sensitivity. If the M selection is too sensitive, then use the L setting. Now, if the SIP is installed higher at 13 feet, the far and near sensitivity could be the H position. So as above, perform the walk test, check and adjust proper sensitivity. Next switch is very important, the detection logic selection switch. Up is the factory default, which is OR mode, and OR mode basically means that either beam of the element pair needs to be crossed to trigger. For AND mode, both need to be crossed together. Let's see that in more detail. So this is OR mode, and this is one of the finger pattern pairs being triggered. That will cause detection because we are in OR mode. Either or both of these finger patterns will cause. This is the other finger pattern, and both together. All that will cause detection in OR mode. AND mode, you need to cover both finger patterns in the pair to get triggering. So that in AND mode will cause. This will cause no detection. The only way to get is to cover both pairs. So be very careful. Default position for this switch is OR mode, which is used for setup, but the OR mode is way too sensitive for practical use. So when you're finished setup, remember to put that switch back into AND position. Very important. The alarm interval. 0 is the default, and what this means basically is, for instance, 15, when an alarm occurs, when an event occurs, No other event can be taken in for another 15 seconds. Same as 30 and 60, so it's to stop nuisance alarms. Just be sure that when you're doing the walk test and setup, make sure it's set to 0. And finally, reporting. So the forms are available online at optexamerica.com/Redwall, and the first form you should complete is a site survey form. This should be filled out by the system integrator before installation. After you fill it out, send it to Optex. The other forms are the installation check sheet and the Redwall site report. These should be completed by the system integrator and submitted to Optex after installation. Now, on receipt of these forms, correctly filled out, your standard warranty for the SIP will now increase to 5 years. That's available for CSIs who have completed the necessary paperwork. He will then get a 5-year warranty on the device. Again, all forms obtainable from Optex at www.optexamerica.com/Redwall. And thanks for your time today. For more information, please see us at www.optexamerica.com/Redwall. Thank you.